Hi guys, welcome to another episode in our ESP32 Adventures series. This is episode 7, creating a USB to Bluetooth keyboard dongle. So in previous episodes we were successful in hooking up a keyboard to the host port, and we've also been successful in outputting keyboard information through Bluetooth. And of course we got several of the other components, the screen and the other bits and pieces working. So that's one of the reasons why we are using this particular Espressif microcontroller here, because it has everything built in. We don't have to plug this thing into a breadboard and hook up external devices to it in order to make it do what we want it to do. Everything is built in. It has the ability, it's got a battery connected up right now. It is running off a battery, and it's able to boost the battery voltage to 5 volts, so that we have 5 volts output on the host port over here, which is feeding the keyboard. Keyboard of course needs voltage, and the whole circuit is running off the battery. And if I plug in this dev port, if I plug that into a power bank or something like that, it can actually recharge the battery as well. So as I said, it's completely self-contained, and it also has LEDs which we will be using. It's got a green and a yellow LED. This LED here is actually signifying that the numlock is on the keyboards. This one here is actually caps lock, and if I hit caps lock you'll see it going on and off. Yeah, I'll hit it. See, there's caps lock on, caps lock off, numlock on, numlock off, numlock on, and we're doing that to test the output of the software. In any case, we're running off the battery right now, and the first thing we'll do is we'll have a look at, I made some changes to the software to make the two libraries that we're using previously. We've got a library there that we're using for outputting data on Bluetooth, and for inputting data from the keyboard on the USB host port. Later on we are going to also do the same thing using this tiny little Seed Studio ESP32-S3 board. I really like these little guys, and this one we're going to attempt to mount inside of an old keyboard that I have. We'll talk about that later. This is a little antenna. It has a little stick-on antenna. That's it here. It's got sticky tape on the other side, and so on. Now this one also has battery connections at the bottom, and I've actually soldered leads on this one for testing, and indeed it runs quite nicely off there, but it only has one USB-C connector, which can indeed work as a host port, but there will be no power on it unless you provide power for it through two of these pins, 13 and 14. So those two over here, I think. Or you have to inject it, which is actually what we're going to be doing. I have a little adapter board that I've made up, which actually allows you to, this is it here, inject voltage from a desktop power supply right into the USB-C port. But if you're using this in a circuit, you'd have to get an external 5 volt supply and connect it to those pins in order for it to work. We'll see that later on. We're actually going to put that thing to its paces. That's why I was mentioning that this one is kind of significant, because it has a boost circuit built in, and we discussed that in previous episodes, how that works, and showed you the circuit and stuff like that. Anyway, so let's have a look at the code first. I made a few slight changes to it to make it work together. I found that the two libraries that, of course, I sourced those off GitHub, and again I showed that in the previous episodes where they came from and so on. There'll be links in the description, and I'm actually planning to publish this code that I've got here that you can play with on GitHub. So if you want to play with it, then you can do so. Those little Seed Studio Xiao boards are actually quite cheap. You can get them on AliExpress for less than $10 shipped. So there's no excuse not to play with those little guys there. Anyway, so what have we got? In the main CPP file here, I have now hooked into the library for the keyboard input has a number of callbacks, so-called. So in other words, when it receives data, it says, okay, it calls back on keyboard over here. And if you then define this class, and it's based on ESP USB host, and then you define the on keyboard method, it then knows to call that when it receives data. But what I have actually done is in the previous episodes we were actually looking at this on keyboard key, and it returns a bit of additional information like the ASCII codes. And now we're not interested in ASCII codes. We actually want the raw keyboard stuff. So I've actually defined a couple of defines here: raw report or key report. And as you can see, we've got raw report turned on and key report is turned off. So that's why this is a bit grayed out. So it is not going to compile that into the program. I figured that, why have code compiling when you're not actually wanting to use it? Might take up some space that we can save for something else. So over here is where I have these defines in the ESP USB host header file. I got raw report defined, but I do not have key report. It's commented out, and that's why that is grayed out. And there's other sections of the code that is applied as well. Platform INI, of course, no change at all from what you've seen previously, where we explain what all this stuff is all about for that particular board. This is to do with the display. Then over here, this is where the internally it has an on-receive method, and when it receives data through the USB from the keyboard, it does some processing on it here. It actually creates this record over here called a report, and it captures the modifier and the key codes, up to 6 key codes. And here again you see I've got those same things that I'm defining. If it is raw report is on, which is on, then it says okay, enable this on keyboard call. If key report is on, then it will do an on keyboard key call, and you will notice that there is a difference over here. It calls the on keyboard key up to 6 times depending on how many key codes are defined. If the key code is undefined, in other words it's 0, then it will not output it. But if it finds any key codes there, and you remember you've got rollover, if you've got multiple keys down, there will be multiple key codes there. So it is going to call this on keyboard key up to 6 times if it is fully filled. But on keyboard doesn't do that. It just sends the run report out to process, and that of course is exactly what we're doing over here. We're processing this, and we're actually displaying it on the little screen which you saw earlier, and which we'll be looking at in a minute when we run the code. So That's all that is there of any significance. As I said, this stuff is grayed out. We don't need that for this at this time. On the Bluetooth side, what we're looking at just now is the host side. We want to be able to output data, which is easily done, but it also has a bunch of methods, of course, for connecting, disconnecting. We're not actually touching those; they stay as they are. But other than an input on the for the LEDs is called output callbacks, and on write it actually, this is what actually is coming from Windows or whatever computer or whatever host you got the Bluetooth connected to. So the keyboard stuff is actually managed by the computer, and the computer, you might have sent it like a num lock or a caps lock or a scroll lock or whatever it is, that a Windows key, whatever it is that it responds to, then it is actually going to send to every keyboard that is connected to the computer. Will get one of these on write messages, and this one here we have defined internally in this code here. I have defined some caps lock and num lock and scroll lock booleans, and different in that report, you know, bit 0 is actually the num lock, and the bit 2 is caps lock, and the third bit is actually scroll lock. And then we say, okay, update the LEDs, and I showed you the LEDs on the board there before, and it's got two, it's got a yellow and a green one, and I've got those assigned. The yellow one is going to be num lock, and the green one is going to be caps lock, and it sets them high or low. So that's the only change that we have made there. I don't think there's anything here, no. And finally, this hid.h file, there's a bunch of header files that actually come with the Espressif S3 core code that is actually comes in with platform IO. And if you want to know where these hang out, you can actually go reveal in File Explorer, because they're very hard to find otherwise, and you'll find that this is actually part of the Arduino Tiny USB code. Originally, I think it might have come from Adafruit. I think they still have it on their GitHub site. But Espressif, I think, have maybe modified it or something, or just included it. I'm not sure. And this is where there are header files. Either there's a device one, there's a host one, and there is the general H file. And it's quite a ways down. It's on my computer. It's on C users info. Info is actually my user ID on the Windows. I've explained before how that actually happened, but that's what I log in as. Then it's got .platform IO packages framework dash Arduino Espressif 32 tools SDK ESP32-S3. See, that's what's significant. We're using all the S3 boards. Include Arduino underline tiny USB source class HID. That's where it is, and that's why you can just refer to those header files, and you don't have to import them as libraries or anything. They're always there. And this, of course, is where the actual HID codes for the keys are defined. See, EA is 04, and so on. And it's got separate key codes for the keypad. The keypad 1 is actually 59, but the actual key for 1 is actually 1E. So it actually, so that therefore the operating system can recognize, which key you hit. because when numlock is on, they get interpreted as something else rather than a number. Alright, so let's run the code and see what we can find out and what it does. Alright, so what we've got on the screen here is I've got the little display on the microcontroller highlighted at the bottom right, and I've got a little window with a notepad in it on the kind of a little bit towards the top on the right as well, so we can actually see the cursor in there, and then we can actually type stuff. Now the first thing of note is that this is the keyboard here, the big black one. It's a cheap Lenovo keyboard that came with a little mini PC about 10 years ago or something, and I never used this keyboard. I had it laying around, but it has a keypad on it and stuff like that, but it doesn't seem to have any LEDs on it. There is a couple over here, but they are for special, they've got a special keys. I'm not sure what those things are all about. In any case, the first thing to note is that, remember I said that when this keyboard is connected to this microcontroller, and it is actually coming out as Bluetooth, and if I go to bring up the Bluetooth thing over here, show Bluetooth devices, and I will have to move it around so you can actually see it, otherwise I've got it minimized. I think you see ESP keyboard over here, it says connected, and remember that is how we got it defined in the code, in the Bluetooth header file. There is a place there for it to give it a name, and I called it ESP keyboard for this particular one. Later on we're going to be looking at the Xiao one, and I called it Xiao keyboard or something like that, so that you can see the difference. In any case, it is connected. If I switch it off, it'll say paired, and as soon as I switch it on, it connects very quickly, so it's working well. And as I said, all the keyboards, if you look at the device manager in Windows and you scroll down on the keyboards, on mine there's like 8 keyboards, because over time I have used different kinds of keyboards on it, and it remembers those and it knows when they are connected or not. And as soon as I hit a special key, like for instance the caps lock key over here, it recognizes that, and then it sends a message. Remember when we looked at the code, you turn the LEDs on, and you can kind of see in the top here, this is the yellow LED for numlock, but the green one is off because caps lock is not on. If I hit caps lock on here, and also watch the key over here, the backlighting, this is how this little keyboard shows the caps lock is on. It removes the backlighting from there. So I hit caps lock, and boom, you see the green LED came on, and the caps lock key the backlighting is off, showing that caps lock is on. And indeed, if I hit a key, see on the notepad there, they are all capitals now, and if I hit caps lock again, the backlighting came back on, the little LED went off, and we are now in lowercase. Great, so numlock is the same. If I right now numlock is on, which means that we're going to get numbers, but when I hit numlock, you see the little key, the little LED went off, and now if I hit 7 for instance, it does home. You see the cursor moves in front of the A now, and hit numlock again, and now it's back on, the little LED is on, and so on. So as far as Windows is concerned, which is the operating system I'm using, of course I'm using Linux or whatever else, it would do the same thing. It doesn't know that there is a device in between the actual keyboard and the Bluetooth keyboard that it thinks that it is. So this gives us some unique opportunities, of course, to capture the keystrokes and do something with them. And we're going to be doing that when we move to the little Xiao board, because as you notice, I'll put the cursor kind of in the middle there. If I hit the insert key, and note on the bottom screen that the insert key is code 49, and I put the name there, insert, and I type, it actually inserts. But if you hit it again it should be over typing, but it doesn't. It never actually responds to that. If you use an editor like Notepad++, and I think proper Visual Studio does it. I'd have to try it. I can't remember. But Visual Studio Code also, it doesn't respond to the insert key. So we'll get back to that later, because we can emulate that. As I said, we can actually make it work. Anyway, so what else is there? Okay, so now, if interestingly, note the 6 keys, they're all 0. So when you hit a key, like this is the A key, you see it's repeating. It's 4, but as soon as I release it, it goes to 0. And again, you see the need for that, because while it is down, Windows will start making the code repeat, but then when it gets to zeros, it will actually know, oh, stop, and it'll stop repeating. Now, let's have a look. This is the end and down key, and we'll hit enter, start a new line there on Notepad. Now, when I hit multiple keys, A, S, D, F, G, did you notice that? When I got 4 keys down, they're all in the same row. It can't handle that, and it puts error codes in there, 01, 01, 01, 01, in all key positions. Release it again, and I'm going to do Control A, and I'm going to say delete, get rid of all that stuff. So on these cheap keyboards here, if I put more than 4 keys in a row, the keyboard itself can't handle that. If you've got a gaming keyboard, they've taken care of that, I think, and you find that you can hit up to 6 keys and it'll just work fine. But this thing too can actually do more than 4 keys if they're not in the same row, like A, S, D, F, up, down. You've got the 2 arrow keys. Now it has 5 actual codes in there. So it is just a limitation of how they're scanning the keyboard in these cheap keyboards. And most standard keyboards actually are the same way. Gaming keyboards, as I said, I think they scan the keyboard in a different way, and they can handle more than 4 keys in a row. Anyway, that was an interesting thing as well. And what else is there? We've done numlock, we've done caps lock. I'm not sure if there's much else to talk about now. This is all well and good, but now let's have a look at this little Xiao board over here and get that online, because now we're dealing with something entirely different. This thing doesn't have anything built in at all, but it does have an S3 ESP32 chip, so it also does have that OTG host mode available, as I said, but it has no power available on this port, so we have to provide that either through those 2 pins or injecting it into the USB port via a little breakout board, which is in actual fact what we are going to be doing, because I made up one of those. Alright, so let's switch over. Okay, so this is the code that I have prepared for the little Xiao board, and as you can see, basically it meant removing a bunch of stuff that is aimed at the Espressif board. So this is as simple as it comes. The platform ini file just got the upload port and the actual seed Arduino ESP32-S3 board configured. Now remember when I showed you that the some of the editors like Notepad and so on don't respond to the insert key, and sometimes you wanted to, like if you hit insert then you can overtype something. It's kind of handy. I don't know why they haven't implemented that, but it shows you how you can actually intercept codes and make them do different things. So what we actually are going to be doing is this. Let's say you got okay, so we got a line of text there in Notepad. You see in the top left hand corner. Now the normal thing is that if you hit a key, it just inserts it, but we can emulate the overtype by saying I'm hitting the delete key now. So let's say we want to overtype 6 with an X, and then delete, and then X. So we can actually emulate that by actually doing the delete before outputting the key. It's simple as that. And this is what we're doing here. Now this code actually is over here. This is not actually complete. This is just test code because we are only responding to the key code 0, and remember there could be up to 6 keys over there. So if you were actually implement this in real life, you would have to have a loop here that actually investigates if there's more than one code available and deal with those. But for the test here, we're typing one key at a time, so we're just using key code 0. Okay, so what are we doing? Well, the first thing to do is to find out if the key that is coming in is actually an insert key, and if it is, we want to go and we got insert mode, which is defined over here, is set to true because it always defaults to inserting. But if somebody hits the insert key and it is currently in insert mode, then we want to go into overtype mode. So we're simply inverting the Boolean value of that variable. So we say, okay, it's not insert mode, so it just toggles through the false, through the false, through the false, and so on. And then depending how many times you hit it. So that's one thing we do. If it is not a insert key, then we need to know if it is actually a text key, because after all, if it is an arrow key or a page up, page down, delete, and all that kind of stuff, then it is none of our concern. We're not actually overtyping. So I created a little method over here. If it is text, this is also not quite complete. There's a few other keys there that could be translated as text, but I'm just showing how you would do this. You'd have to fine-tune it, and I think there's one more keypad key, like a comma and so on, that you would also have to deal with if they come in. But this gives you a bit of an idea. So now, if we look at the key codes in that hid.h file, remember we were looking at before, you'll find that they're all contiguous. So A starts at 04, and the hit key 0 is actually hexadecimal 27, but there's also, if your keyboard has a keypad, like the big one we got here, then if it is a keypad 1, up to keypad equal, they're contiguous, and then, as I said, there's one or two more keys in there. You'd have to look them up and add them to this method over here, function, whatever you want to call it. Anyway, if it is text, then we want to actually create a new report, and we'll base it on the existing one, because if there's any keys down like shift and so on, you want to know about that as well. Then you create a temp report, and you will say, okay, give it the delete key code. So we hit the right mouse button there, and send that as an input report, and it actually sends that out, and therefore it will delete the character that's currently under the cursor, and then you can send the actual report that it received, because that would be the character that has to be overtyped, but it will be inserting it, so it will appear to be overtyping. So we'll see that happening, and there is very little else in here. The setup has got hardly nothing in it, because this little board doesn't have a display, it doesn't have anything, so we are basically just setting up we do have a little LED built in, so we set that to output mode. This is the Bluetooth task, and USB host, we tell it to begin, and we tell it that we're international, local standards, whatever it is. If you got in a different country, you can actually define what your keyboard is, whether it's Japanese or English or whatever. Anyway, British English. So that's all that there is to it. Now, with that little Xiao board, we haven't, because it is simple and only has one port, of course we have an additional problem, and that is that if we plug it in like so, and it's got some code running in there, but it has actually configured that as a host port, so Windows is not actually recognizing it as a, and therefore we'll go over here, see it's normally COM14, it's not listed. So if I try to upload code to it, it will say failed, there is no such port. So what you have to do with these little boards, and most of them are the same, there is a tiny little, let me see if I can get the other camera going here, you can see it a little bit better. There is a tiny little button with a B next to it, you see it over here, and you actually have to hold that down, and it's very hard to hold down even with a nail. So I'm using this little tool over here, and you can kind of feel it when it's down. You feel a little click. I'm not feeling it yet. It's still on it or something. Yeah, now I can feel it with a little click. And then I've got to try to hold it, and then I have to plug in the USB. And now you hear the ring, and now, as you can see, the yellow light is not on. And now when I hit the camera off, now when I hit go over here where it says auto, and there it is, COM14 is now there. So now I can actually say, okay, upload the code. There it goes. So that's something to remember when you're using these little boards, and you're going to be using it in host mode. Some of you, if you're not familiar completely with these things, you might say, hey, my board has been bricked or something. No, it's not. It's just how it works. Okay, I'm going to disconnect it now, and now what we're going to be doing is back to the camera here. I have, as I said, made up this little breakout board. This is currently connected to my desktop power supply, so I'll turn it on, but I won't turn the power on yet. So I can plug that in there. Now, if you're wondering, these are there's some wires on there that I have soldered up. This particular little board, it doesn't connect any pins to anywhere, it just goes straight through, and you can actually cut the little traces between those little pads if you want to disconnect some of them and so on. It's just made for like a breakout board. But the actual Type C plugs, they are bidirectional, and let me bring that up so you can. Okay, so you see over here, this is what we're dealing with here. This is the actual receptacle, and on each end there are ground pins, and because it has to be reversible, they are duplicated, mirror image of them on the other side. But you'll see that there's ground pins A1, B12, A12, B1, and the V bus is the 5 volts, so that's A4, B9, A9, and B4. And that's all I've done, is I've actually soldered wires between A4, A9, B4, B9, A1, B12, and B1 and A12, so that I'm actually applying power to all 4 of those pins at the same time, and I am having ground connected to all 4 of those pins at the same time. That's what those wires are for. I thought I would highlight that because you might be thinking, what the heck is he plugging in there? Okay, so that's where the name comes from. See the device name over here in the BLE hit KBH file. So that's where you define the name, and that's why the Xiao keyboard connected. Alright, okay, so let's try it out. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll actually key that in on the, this is the keyboard that's connected to the little Xiao board over here. And again, caps lock works as you thought. Now, remember we put that code in there for that insert. So right now it's default to insert mode, backspace, backspace. Now if I hit the insert key and now I hit the X key, the 5 should be overwritten. Yep, it is. So our code that we put in there is working. We're intercepting the insert key. Now if I hit it again, hit the Y key, see now it's in insert mode again. So it gives you a little bit of an idea of the power that you have if you put one of these things in line with a keyboard. You can pretty much do anything. You can record keystrokes, you can give it macros. If you're using an ESP32 board with a built-in SD card interface, then you can actually store data on there. So you can actually store, create macros or something like when a particular key code comes in with some modifier keys like Alt, Control, whatever you want to do, then you can output a whole string of data and so on. And you can reconfigure keys, and you might be, you could actually set it up for a gaming mode or something and have different keys in that mode than you have in typing mode, whatever. The world is your oyster, as they say. Anything is possible. Okay, so that is all I've got for now. But the reason why we're actually working up to is that we want to be able to, I've got an old keyboard. Let me get rid of this. I have an old keyboard here. Let me grab it. This thing is huge and it weighs a ton. It's got a metal base on it. And let me move this keyboard out of the way here. This guy I actually bought in 1990 as a very young software engineer, and this was the best keyboard you could buy at the time. It's one of the first mechanical keyboards, and you know guys, it feels really nice, much better than these new mechanical keyboards in my opinion. It is really good quality, and you know, at the time they had the original IBM PC keyboards had function keys on the side, so they actually put function keys here and they put function keys there, and these actually by default are shifted function keys, but you can modify that. It has this special key over here that you can actually change the mode of the keys and all sorts of stuff. It also has a it came with a spare set of keycaps, and it's got this you can program the keyboard to behave in a different way, like the Dvorak format. It has a bunch of output sockets over here that you can use. This is the one. It's actually compatible with a PS2 keyboard, so it's not USB. And I'd have to look up the circuit again. I can't remember what these other two sockets are for. And this is a reset button here. I don't know what that is. So I got the idea that this keyboard actually is so old. It actually came with a with this great big DIN plug, which is what the original PCs had. Because I had an adapter for it that I used for some years. That converted it to a standard PS2 socket, but the pinout's exactly the same, it's just smaller. So I got the idea of actually using the turning this into a Bluetooth keyboard just for the heck of it, and then I can use it. This I figured that there should be some space in there. This thing here can be stuck to the top underneath. That's the antenna, of course, and running it off this little tiny Xiao board. But I'll have to add another little board. I've got little boards that are not much bigger than this, that will actually allow you to connect the battery, and it will boost the voltage to 5 volts, and it will charge them as well. So that will also have to go in there, and just for fun, see how that will work out. So that's what we're working up to. That's why we've been doing these investigations and how these boards work and stuff like that, to get a handle on what resources we have available to do this sort of thing. So that's what we are going to be looking at. Now, this keyboard here, as I said, is a standard PS2 keyboard. They're actually even easier to interface to. You can just hook them up to a couple of GPIO pins on this thing and pick up the scan codes, but then I would have to translate the scan codes to HID scan codes. So that's, I think we might do that in the next episode, but then the one after that we're actually going to be pulling this thing apart and actually putting it all together and see what we can do. This thing actually has some LEDs here, caps lock, num lock, and scroll lock. So we're going to see what's the easiest way to access those and stuff like that. So it's going to be interesting. Anyway, that's all I've got for now. Don't forget to subscribe, like, and to get notified when new episodes come. And I will see you guys later. Bye bye.